So next question. The primitive function of, what does primitive mean? Yes, correct. So primitive is just a fancy way of saying the integral of the following function is. No. So first of all, we'll do this one kind of together. Actually, no. Have a go at this yourself and give me an answer. Good. Your numerator has to be the derivative of your denominator. So what does our numerator have to look like? Do it yourself. Don't say it out loud. Do it yourself. Elisa, you too. Do it yourself. Elisa, have you gotten an answer yet?
I got B.
Good. Correct. That is B. Shivani, were you able to get B? No? Okay, we can go through it. Elisa, I'll get you to explain to me what you did, and then we'll go through what you did, Orbis, and then we'll go through the correct method. Elisa, so what did you do?
So the differentiated version of the denominator should be 2x plus 4.
Beautiful. So we want our numerator to be 2x plus 4 and our denominator to be x squared plus 4x plus 3. Then what did you do from there?
And because you times the numerator by 2, you would also times it by a half.
Good. So what Elisa did is, first thing you did, Elisa, was you looked at your fraction. Did you like it?
No.
No, we didn't like it because it doesn't look like the derivative. So we have to make it look like 2x plus 4, right? So Elisa figured out that the derivative of our denominator is 2x plus 4, right? The derivative of just this is 2x plus 4. Now, what did you do to the existing numerator? So remember, we're manipulating our existing numerator. What did you do to our existing numerator to get 2x plus 4?
I times it by 2.
Good. You timed it by 2. But because timesing it by 2 changes it, we have to do the opposite. So you also times it by?
1 over 2.
Good. 1 over 2. So half. So by multiplying it by half, we bring the half out and we keep the numerator the way that we like it. Does that make sense? Yeah, kind of. Yeah. So I'll explain it. Oh, I don't know how to explain it. Okay, so step number 1. Do we like the fraction? Is the first thing we're going to figure out. That's whether we want to manipulate it. Step number 2. What do we want the fraction to look like? Right, Elisa? So you wanted the fraction to look like 2x plus 4 over x squared plus 4x plus 3, correct?
Yeah.
Beautiful. Then what was the next step you took? What do we want the fraction to look like? What do we do to the existing numerator to get our new and improved numerator? So in this case, what did we do, Elisa?
We times it by 2.
Good. We times it by 2 because so x plus 2 multiplied by 2 is 2x plus 4.
Yeah, that's the derivative of the whole.
Yeah. So what we're doing is we're first finding out what our numerator should look like. Our numerator should be 2x plus 4.
Yes.
Then to make what we already have into 2x plus 4, what do? We multiply x plus 2 times 2. And remember, x plus 2 is treated as one term. Yes. So you have to multiply both terms by 2. Yes. So that's what we're doing. So that's step 3 here. What do we do to our existing numerator to get our new and improved numerator? Yes, good. So your new and improved and the numerator that you want should be at the front or inside your numerator sign. Why did you put half on the outside, Elisa?
To cancel out the
Good.
we times it by.
Very good. So our next step is cancel out this change by multiplying by the reciprocal, right? So the reciprocal of 2 is 1 over 2. So we multiply it by 1 over 2. And we keep our 1 over 2 on the outside of our integral. So keep this outside of integral. And then step number 5, integrate. So those are your 5 steps for manipulating equations. Does that make sense?
So when you think about it, will the top always be 1? So in the fraction top, will the top, the numerator always be 1? Like outside of the
Yes, so this one.
always be 1.
Well, it depends. If you multiply it by 2 over 3, if you multiply your function by 2 over 3 to make it look the way you do, what's the reciprocal of that? Good. So it depends on what you multiply it by. More often than not, it's just a whole number constant. But on the offhand occasion, you might have to multiply it by, I don't know, 2 over 3. And if you do that, the reciprocal of that is 3 over 2. So you put 3 over 2 on the outside of the integral. Does that make sense? So you know how in this case we just... Yes. No. Just 3 on 2. Remember that the number that you bring to the outside has to be a number. If it's x, you can't take it out. If it has x, keep it inside. You can't not integrate it. Very well done, Elisa. Good job. But does that make sense? A little bit more sense? We'll do more. Don't worry. Don't be intimidated. It took me a really long time to get manipulating, so it's okay if you don't fully understand now. Good. And then what is the integral of our newfound integral? Our newfound equation, Elisa.
1 over 2 ln
Very good.
x squared plus 4x plus 3 in brackets
Beautiful.
plus c.
Good. Very well done. So plus c because it's undefined. And then remember that your integral, so the integral of f dash x all over f of x is equal to ln of just f of x. That's just your rule for integrating. Yeah? Does that make sense? Okay, beautiful. So the correct answer for that one was B. Very well done. Have you written down your steps to manipulate fractions? Yeah? Okay, beautiful. Do you need to write them down or you think you just need practice? Practice, okay. How about you, Lisa? Do you want to write that down or do you think you've got it?
I've got it, but I have a question.
Yes.
When we're writing it, do we need to include the absolute value sign?
Yeah, I'd say so. Better be safe than sorry. I never did, I'll be honest. I never really did. But yeah, keep your absolute value sign. Because your absolute value sign makes sure that it's always positive, and it also acts as a bracket. So it kind of kills 2 birds with 1 stone. So yeah, keep it as positive. But if your answer doesn't have it as absolute value signs, you don't have to. But you can, depending on your question. Cool. Any other questions? All good? Okay, beautiful.